All right. Today our objective is to graph secant and cosecant. If you could graph sine and cosine, you can do this very easy. No problems. So we're going to take just about 5-10 minutes here and talk about kind of the analytical approach to understand these graphs. It really makes you have to understand the behavior of sine. Where does sine start, the parent function? Starts at 0. So at 0, sine is equal to 0. Okay? What's the normal period for sine? 2 pi. So if you divide up into 4 parts, you get pi in the middle, and then pi over 2, right? You got pi over 2, pi, 3 pi over 2, 2 pi. So after sine's at 0, it goes up to 1, and then it comes back down to 0. Where does that happen? Halfway in between, or pi. After pi is in the, it's at 0, okay? Then it goes down to at 3 pi over 2, and then it comes back up to 0 at 2 pi. If we graphed sine if we sketch that graph, those are the values where it's equal to 0. 0, pi, 2 pi, right? And it just continues on and on and on and on. So, 0, pi, 2 pi, it would happen again at 3 pi, 4 pi, so on and so forth. That's important to us, because if sine is equal to 0 there, what's the relationship between sine and cosecant? Reciprocals, yeah? What's the reciprocal of 0? Undefined. So if sine's equal to 0 there, then cosecant is undefined there. If it's undefined, what shapes do you think I have at those spots? Yep, vertical asymptotes. All right, so let's piece that together. When you want to graph cosecant, it's helpful to think of what sine looks like. So we start by graphing sine. There's no vertical shift for this one. The maximum value is 1. The minimum value is -1. 2 pi. I'm going to put 1 period on each side, and that's what you should do for your assignment today. 1 period on each side. Where does it start? Starts at 0, goes up, down, down, up. Kind of play our connect the dots game. You tell me when I get to a spot where sine is equal to 0. Tell me the next one. Yep. You see that where it crosses this x-axis, it's equal to 0 there, right? So what shapes do I have there then? So once you draw the sine graph, you can then draw vertical asymptotes for where it crosses the x-axis. sine graph is not actually my graph. Vertical asymptotes are not actually my graph. This is all just helpful work to sketch what I'm going to do right now. This is the hardest part to think through. You won't have to do it again. I'm just trying to explain to you why it gets the shape it does. What's the relationship between sine and cosecant? Reciprocals. I find a value for sine. Right here, sine has a y value of 1. What's the reciprocal of 1? 1. 1. Very good. Very good. 1. Okay. Now, I know that point. Let's think about what happens then, okay? That for this sine graph, all the values are between 1 and negative 1, right? So they're like decimals or small numbers. What's the reciprocal of a small number? A big number. Like if I give you the number 1/20th, the reciprocal of 1 over 20 is 20. That's a big number. So if you look at, say, negative 2 pi, if I go just to the right of negative 2 pi, does my sine graph have a big number or a small number? My sine graph, the green graph, small number. So cosecant is going to have it's going to have a big number, something way up there. Look at this spot where my marker is right here, okay? I'm at 0, then I'm going to move just to the left. Does my sine graph, the green graph, have a big number there or a small number there? And the reciprocal of a small number is going to be a big number. That black portion right there is part of the graph of cosecant. Watch what happens. We'll do a different one, okay? Let's look down here. What's the reciprocal of negative 1? Negative 1. Now I'll go just to the side of negative pi. Does the graph have a big value or a small value? It has a small value, but it's negative, right? What's the reciprocal of a small negative number? A big negative number. And then if you look at this spot right at 0, if I move just to the left, sine, the green graph, has a very small negative value. The reciprocal of a small negative value is a big negative value. And so you just end up with, you know, at the maximums and minimums of sine, you get these type of U shapes. They're not parabolas. Parabolas go on forever in the x direction and the y direction. I'm sorry, they go on forever in the left and right direction, okay? Their domain is all the way across. But these kind of, you know, they're shaped by these vertical asymptotes, and so that's the shape you get. So the black is the actual graph. Those dotted lines are just how I construct the graph. What do you think? The next one will go really quick because now you guys see it, okay? Cosine of x, if you think about it, remember cosine, where does it start? Yeah, it starts at the maximum here. So I start up at the maximum, and then I come down, down, up, up. I go like that. Okay, that's my cosine graph. All right, we got that. So is cosine equal to 0 at 0? No, it's equal to 0 at pi over 2. Then at pi, it goes down to negative 1. Then at 3 pi over 2, it comes back to 0. So on and so forth. Values like that. Well, what's the relationship between cosine and secant? They're reciprocals. And what's the reciprocal of 0? Undefined. So therefore, secant is undefined for those values. Pi over 2, 3 pi over 2, 5 pi over 2, stuff like that. And so there's vertical asymptotes at that spot. So really the same type of graph, just things shift a little bit. Okay, things shift a little bit. So instead of graphing y equals secant of x, what do you think I start by graphing? Y equals cosine of x. Put my 1 and my negative 1. The period for cosine is 2 pi. I'll put that on the right, on the left. Divide it up into 4 spots. You like triple jump, Preston? Okay. Just curious. It just gets so nasty. Because we're going to get so many other dashed lines. I just don't want to confuse you. Okay. Now it's time to graph. Cosine starts at the maximum here. And then I'll head down. Cool. Remember how long it took us at the beginning to graph sine and cosine? And now it's like, well, that's old hat. Yeah. What? Whoa! Scott! No way! Here's what they do in soccer. You know what they do in soccer? Red card. We're just going to go straight to red card, right? Sydney? Is that a red card? Red card. You're gone. Boom. He says it would take us a weekend to forget it. Scott, I expect that from Emily. She's kind of mouthy. I don't expect that from you. Unbelievable. All right. Okay, so that's what I have. I have my graph. And what do I do next? Vertical asymptotes. And that will happen whenever the graph crosses, over the x-axis. You just draw your U-shapes at the maxes and the mins. What do you think? Sine and cosine behave the same way, right? Remember when I took sine and cosine and I picked up the cosine graph and I put it over the sine graph? It was just shifted a little bit. The key lies in here. Sine is always between 1 and negative 1, right? So if we take the reciprocal of all the values between 1 and negative 1, we're going to come up with values outside of 1 and negative 1. So therefore, if you look at secant and cosecant, they take on values way above and way below sine and cosine. The reason why we get this crazy asymptote piece is because, like I said, because sine achieves a value of 0, its reciprocal will be undefined. Yep, we'll see that when we'll do one vertical shift. So let's outline our steps real quick. Steps for graphing cosecant and secant. Graph sine of x for cosecant of x and cosine of x for secant of x. So that's what we started with. We chose sine and cosine for the appropriate functions that they were related to. And we decided to draw vertical asymptotes at the zeros. After we did that, what shapes did we draw after that? At the minimum, we drew U shapes, and they were down. And at the maximums, we drew U shapes, and they were up. And we talked about why they looked like that. Just to show that those are minimums. Same question last hour. They didn't ask for this stuff. They weren't paying attention. Yeah, exactly. Very good. All right. So here we go. We got 3 examples. For this last one, we are going to do a vertical shift because that's what people are wondering about. So we'll do +1. Instead of graphing 2 cosecant of x, I start by graphing y equals 2 sine of x. That's what I'm going to start with. Is there a vertical shift for y equals 2 sine of x? No. So what's the amplitude? 2, so I go up to 2 and down to -2. Got to leave some space for your secant and cosecant graphs, so you don't draw your 2 all the way up and your -2 all the way down. Okay, so I've got those. Period. 2 pi, put that on the left side and the right side. Any horizontal shift? No. So I can graph my sine graph. Where do I start? 0. And I head up. It's hard for me to tell where your shapes come from. I like to see it all for this. So on your test, I give you credit for your graph based off of whether or not you've shown the sine function and the cosine function, because those are the mistakes that people make. So like they graph the wrong function, and so that helps me kind of keep track of what you were doing and why you're doing it. Okay, what now? Asymptotes. Right where it crosses through the x-axis. So that's the rough sketch of how I then draw my graph. The last step is to put on the U shapes. Cassie has a question. For like right here. Yep. So I grabbed this spot because that's where cosine is or sine has that value. So that wasn't a very good explanation. I just like I was gonna say because the reciprocal of 2 is 2, but that's totally not true at all. The reciprocal of 1 is 1, and then it gets multiplied by 2. That's why they have those same values. So, but I realize that's a lot more difficult to kind of talk through. Okay, so this one right here, I graph y equals -3 cosine of 2x. Does that have a vertical shift? No. If there was a +1 on the end or something, then it has a vertical shift. What's the amplitude? 3. What's the period? Pi. Is there a horizontal shift? Nope. No horizontal shift. Where does this cosine graph start? I think that's what you said, Sid. It's kind of trying to read your lips. Vertical asymptotes? Now just draw your U-shapes. So now I can tell that you guys are different than the other classes because both other classes said this. They said it looks like Christmas. Did anybody think that? Before I drew the blue, they said, hey, it looks like Christmas. Just thought math. Okay, all right. The other thing that they all said, they said, why did you put a 6 up there that time? Anybody think that? Okay. I just wanted to. I could have put a 4 up there to show another tick mark. All right. And now is where I get to show you this. Do you have a button for secant on your calculator? You don't. And so when I go to graph this, I have to type it in like this. -3 divided by cosine, because secant is 1 over cosine. So I do -3 over cosine of 2x. Because -3 is not reciprocal. I don't have a really good explanation for that right now. Secant of something is equal to 1 over cosine of that something. So if you simply substitute that in, it is -3 over 1. So it's -3 over 1 times 1 over cosine of, and what is in place of u? It's 2x. So 2x, it's there. So we get -3 over cosine of 2x. Move it to the I don't know, I'm not sure. Maybe wait till we do this one where we got the horizontal shift, see if that works. So I've got it in there like that. If I set my window appropriately, I've got my window, and I press graph, and there you go. Looks pretty much the same. Okay. All right, last one. This one can get confusing. You really got to make sure that you're watching. Last hour was a little bit chatty during this time. They kind of got lost a little bit. But you guys will be very focused, I know. So y equals negative secant of x plus pi plus 1. Instead, I'm going to graph y equals negative cosine of x plus pi plus 1. This would be the most difficult type of problem you'd be asked to do. This is a challenging problem. But you can do it. Vertical asymptote, amplitude, period, horizontal shift, because we've got a lot of components here. All right, so is there a vertical shift of 1? What's the amplitude? 1. What's the period? Pi, and the horizontal shift? Negative pi. So let's kind of apply those in the order we talk about. Okay, vertical shift is up 1, and the amplitude is 1. So what's going to be the highest point that your cosine graph would reach? 2. So I want to make sure if that's my highest spot, that way my secant graph will be up here. So I want to make sure I leave room for that. So if there's a vertical shift of 1, you guys remember we draw our imaginary line through here. It's kind of its rotational point. Kind of moves along that. So I've got my vertical shift, my amplitude. The biggest value is going to be 2. The smallest value will be 0. Period is 2 pi. It's like, why did I make the graph that big? Because it was a hard problem. Does it need a big graph then? Probably not. You do stupid things as a teacher all the time. It's kind of like when I talk louder when material is more difficult. I think, well, we might understand it better if I talk loud. Makes no sense, yeah. Well, because the cosine graph is going to be in this region, right? But this space up here will be where the secant graph will actually draw. I'll draw the U-shaped portions up here and down here. So I just want to leave myself room. Does that make sense? Okay, so I've got that. I have so much space, so I don't know what to do with it all. So I'm actually going to draw an extra set of rotational points in here. So we'll go, my period is 2 pi, right? So I'll go 2 pi and negative 2 pi. I'll divide those up into 4 spots. And then I'll go another one. Just because we got the extra space. Again, I don't really know why I did that. Maybe I was thinking I wanted to graph it at the end. I want to show some really cool graph on the calculator. Oh, I know what I was thinking. The horizontal shift is negative pi, so I had to have enough room. But I didn't really need to graph that big. Okay, we've got it all there. Now, I haven't done the horizontal shift yet, right? Before I did the horizontal shift, we drew a rough sketch, right? So I'm actually going to have 2 rough sketches. I got a rough sketch before I do my horizontal shift, and then I'll have that normal red graph. So I'll draw my rough sketch right now in green. This is cosine, it's negative, so where's it going to start? 0. Okay, now it's time to apply the horizontal shift. If the horizontal shift is negative pi, how many tick marks do I move? 2. And do I move to the left or the right? Move to the left. So I take my tick marks, move them 2 to the left. And I kind of see the pattern developing here. Yeah. Oh. We can prove that in 2 units. That's what you want. Proofs, right? I know you're confused. This is the same thing last hour. You must have been talking to Cassie. So the green graph was my graph before the horizontal shift. My red graph is the one I actually want to use. It was like the red graphs up there. So the difference is now I'm ready to do my vertical asymptotes, right? But my vertical asymptotes, I'm not going to put them where it crosses the x-axis. I'll put them where they cross that middle point. So I look at the red graph, and the red graph crosses the middle right there. So I put my vertical asymptote right there. Is that? If we tried plugging in values, for example, like -3 pi, or let's pick an easier one. Let's pick pi right here. So the graph, you see it at 0 right here. If you pick pi and plug it in, pi plus pi is 2 pi. Do you know the cosine of 2 pi? It's 1. And so the secant of 2 pi is also 1. Make it -1. Plus 1 is 0. So you can see that secant actually has a value of 0 there. So when you have a vertical shift, it also shifts where you decide to place your vertical asymptotes. It's going to go through the middle part. Okay. Yep, without a doubt. So now I take the red graph. Remember, the red graph was our last graph, and that's where I put my maxes and my mins. Cool. Yeah, you graph that, and that's where then your mom and dad make a phone call, and they're like, having you tested to see if you're a genius. And like, well, you should see what they're doing for their homework. And you're sitting there like, oh. 7 problems. 4 of them are real quick ones, like we did at the beginning. Remember, we generated 5 graphs during that time right now. So 4 of them are real quick. And like I said, I got stuff for us to practice on Monday. Tuesday, all day to work on study guide. So, do you know now how to do everything in study guide? And it's just a front and back. So I don't think we need, Tuesday and Wednesday to kind of practice everything. I think with giving you time to work and practice in class constructively on Monday, then you just need that Tuesday time. That way we save another day which is pretty big because we've lost a few days here, and I want to again try to get to the point where we can be ready for the final exam, which is very challenging for me because you seniors, you're not here the last week, right? So now I've lost 2 weeks on top of the 5 days, so I've really lost 3 weeks from last year. You know what I mean? I won't be able to regain all 3 weeks. I'll have to adjust how we do the final, but I'm just saying that's why we need to keep at a good clip. So there we are. You guys did very well this unit. The unit's done. That's what we test on. This is a great opportunity. These next 2 tests are great opportunities to get a real good test grade. Real good test grade. So it's confined material, okay? Confined to just our nice little graphing these trig functions. Good luck.